All right. I will. I'll begin with a word of prayer here in just a second. I will begin with a word of prayer. I will start. Dear Father, we thank you for today. Thank you, Lord. I thank you for the students. Pray you to help us use this time wisely. Just to wrap up any questions that remain about the homework. Lord, in your name I pray. Amen. All right, what you guys want to ask me about?
I got one 10.4, 66.
10.4, number 66.
Yes, sir. Because I went to YouTube and...
YouTube.
Yeah.
YouTube. Those are funny. 10.4, number 66. We are asked to find horizontal and vertical tangents, if any, to the polar curve. R equals to a sine theta. I mean, I guess you could make this more complicated, but the way I would do this would be r squared is AR sine theta, which is x squared plus y squared equals to AY, which is x squared plus y squared minus AY equals to 0, which is x squared plus y minus 1/2 a quantity squared equal to 1/2 a quantity squared. This is a circle centered at here, and that here, of course, is 0, 1/2 a. I'm assuming a is positive. I guess a could be negative, whatever. And so where are the horizontal tangents and vertical tangents to that? Did it go all the way there? I mean, I don't think you need calculus to figure that out. I mean, this is a horizontal tangent. These are the vertical tangents, right? Y equals to, up here, where is that point? This is what? This is y equals to a. This is y equals to 0. And the vertical tangents, I would see, that would be x equal to what? What? No, I mean, you could say it. What I didn't, B. There's no B here. B. Oh, B is a variable. Oh, okay, B is a variable for the right answer. So you might be a math major yet. Let's see here. It's the kind of sarcastic nonsense I expect. So this, I mean, if this is the radius, right? This distance right here is 1/2, right? A over 2, assuming A is positive, as I have in my picture. This point is at A over 2, comma, I guess A over 2, huh? So, I mean, this one over here, this point where the vertical tangent is at minus A over 2, A over 2. Anyway, the point is x equals to A over 2 and x equals to minus A over 2. Those are your vertical tangents here, I believe. Now, would you like me to do this with calculus? We could do this with calculus if you'd like. To parameterize, here's the parametric. Yeah, but what if you're like, but that's great, but what if you can't magically see that it's a circle? Yeah. Parametrically, you can say x is equal to r cosine theta, y is equal to r sine theta, right? So in this case, r is what? R is a sine theta cosine theta, right? A sine squared theta, yeah? So what is the condition what's the condition for a vertical tangent?
dy dx has to be equal to 0.
dy,
Oh, sorry,
d-
dx dy has to be equal to 0.
I think I think dy d theta has to be non-zero, and dx d theta has to be 0. I mean, if they're both 0, I don't know what's going on there. I'd have to limit it. I have to approach it in a limiting sense. But if dy d theta is non-zero, but dx d theta is 0, that means I'm passing through a point in the vertical sense, you know? So we just gotta, what's dx d theta? Well, it's d dx of, you know, this is better understood as is a over 2 sine 2 theta, yeah? So that's d d theta a over 2 sine 2 theta equal to 0, which gives me what? That gives me a cosine 2 theta equal to 0. What are the solutions to that? What's that?
I have that on my paper. I had no idea that I was even close to being.
Yeah, then what theta makes that 0?
Arc sine 0 over 2.
How about if 2 theta is plus or minus pi over 2, then the cosine is 0, right?
Oh, okay.
But what is that? That means that, yeah, theta is plus or minus pi over 4. So going back to my picture, you can see that that agrees with what I found through other methods, right?
Yeah.
Here's pi over 4. Here's minus 5 pi over 4. There's your vertical tangents, just like we found. Now you take those and you plug them back in. Now you have to take that, right, and plug it back up in here to get the point. And what's a vertical tangent? Vertical tangent is x equals to blah,
Yeah.
right? Then for the horizontal tangent, we have to solve,
For dy d theta
right.
equal to 0.
Which gives me, you know, 2a sine theta cosine theta equals to 0, which is, by the way, the same as a times the sine of 2 theta equals to 0. So how can that be? I mean, if we put theta equals to, so if 2 theta is either equal to 0 or pi, you know, etc. So this, then that implies that we have theta equals to 0 or pi over 2 for my horizontal tangents. So I don't know, how do you find horizontal vertical tangents? I mean, it depends on what's the most convenient way to look at your problem. I mean, geometrically, sometimes is easier, right? I'm happy with either one of these ways of thinking. But I will admit, this is limited to, yeah.
If I had this as my answer, I mean, it's the same. If you do it on a calculator, it's the same as pi over 4.
Yeah, but that's not, that's lovely, but that's not the point. I mean, the vertical tangent, you should say, you know, y equals a, y equals 0, or x equals a over 2, well, x equals minus a over 2. Those are the equations that the answer should properly be.
Okay.
If you tell me theta is inverse cosine of 0, that's not, that's unfinished.
Okay.
I mean, we know what inverse cosine of 0 is. Inverse cosine of 0 is pi over 2. Because cosine of pi over 2 is 0. But you have a calculator, so that's not, I'm not being draconian here. I mean, I can imagine a world where you take calculus tests without a calculator. Right? No? My brother doesn't let people have calculators on his exams. Yeah? No. He's a professor at Appalachian State University, which is, of course, a, you know, very elite university. I'm kidding. I mean, that he doesn't let them have calculators means it should be a fair thing for me to do here. An entrance general student population, pretty similar in makeup. Actually, about the same size schools. Like, what do we have here? 15,000? I think Appalachian's got about, I forget. Actually, I think about 15. Yeah, 15, 16. Yeah.
My buddy goes there.
Yeah. Although I think the traffic is worse in Boone.
Really? Yeah.
The traffic in Boone is. I was there. Like, I took some classes at Appalachian. I used to take Calculus 2 there, Calculus 2 and Physics 2 there in the morning. Then I would drive to the community college, which is like an hour away, and then take night classes, and then repeat. And when I was doing that, the traffic wasn't that bad. Like, now I go back and visit. Over fall break I went, and it was just, the traffic was amazingly bad. I think I'm used to the traffic here. It doesn't affect me as much. I'm parked on Ward's Road. I'm just kind of like, I just accept it, you know?
Yeah. Went over there. And also driving up there,
Can I race?
ears pop because of the altitude.
Oh, yeah. Yeah, if you're not expecting that and you got like a head cold or something, it'll mess you up. All right, what's the next question? Is that good? Did you have a question? No? 10.5 number what? 40. Here we have supposed to find the area. Oh, this is good. Common interior of r equals to 2 cosine theta and r equals to 2 sine theta. We're supposed to find the area of the common interior of these two things. Now, we could use my technique of polar graphing, but I guess I'll do that. I mean, these are both circles. If I multiply by r, I can use the trick I just did again.
If you use polar graphing and you set the boundaries to be the sector that both
The common interior.
the common interior that they both include.
Yeah.
If you set that if you set the bounds according to that, bounds include area from the other circle, from the circles that's not.
Well, I'm gonna have to see that. I'm sorry. Let me give me a second here. So 2 cosine theta, what's that? 2 cosine theta starts at 2. That's one of these deals, right? So this is 2 cosine theta? Yeah? And so let me just go ahead and plot that one. So at 0, so here's 0, here's pi over 2, pi, 3 pi over 2, 2 pi. So at 0, I'm at 2, right? At pi over 2, I'm at 0. At pi, I'm at minus 2, which means I'm back here again. Aha. So it looks like if I just focus on this piece right here alone, it's the full story. It's like I've looped back. So I think that is just this circle like that. If I continue going, I just keep wrapping around that circle again. Yeah. So that's, you agree?
Yeah, that's
Okay. And on the other hand, if we are 2 sine theta, well, that's this guy, right? So that starts at 0, and by pi over 2, it's swung out to to radius 2, right? And then by the time it gets to pi, it's back to 0 again. So that's one of these guys. I can see that just from, I didn't even use this. This is just the same thing again. Just like this was just the same thing again. I've already got everything from the undotted part. So what's the common interior?
Like that leaf thing right in the middle.
Right. So in here, yeah, that's what we want. So it looks like, let me blow that up a little bit. All right, if you can understand my picture. Now, if you look at that, what's this point right here? Right. Now that's where the r's intersect, right, at the same theta. So that's where 2 cosine theta should be equal to 2 sine theta. Now you guys already told me that's pi over 4, but let's derive that, yeah? Tangent theta is 1, theta is equal to inverse tangent of 1, aka pi over 4. So it's not just an accident of my picture. Algebra proves that that point of intersection is pi over 4. So if you look at that, if we go from the origin, right? We've got this, that was supposed to be a line, but this is theta equals pi over 4, right? Now, down here, theta equals to 0. Up here, theta equals to pi over 2. So we're actually this is I'm glad you guys asked me about this one. We haven't run into anything quite like this in an in-class example just yet. But you see we have to use 2 different radiuses. Not an r in and an r out, but a r for one part and r for another part. They're different r's. See, if I draw a radius here, then r is equal to what? Two cosine theta, right? It's from the red circle. But on the other hand, on the top of this, r is equal to what? R is equal to 2 sine theta. And if you study that, you see that any line that I draw in here, right, it's going to have 2 sine theta as the radius for the top part. And it's going to have 2 cosine theta for the bottom part. And this, of course, is for pi over 4 less than or equal to theta less than or equal to pi over 2, whereas that is for 0 less than or equal to theta less than or equal to pi over 4. But I think it's fairly evident. We can just take either one of these and double it by the symmetry to get the area. If you don't believe me, just do both integrals. It's cool. So the area, 1/2 integral from 0 to pi over 4 of 2 cosine theta quantity squared, right? 1/2 r squared d theta plus 1/2 the integral from pi over 4 to pi over 2 of 2 sine theta quantity squared d theta.
If you go from pi over 4 to 0, though, doesn't that include part of the 2 cosine theta circle that is not interior?
Have I misidentified which one I'm on? Oh, you're right. I think I have it exactly backwards. Thank you. You're right, you're right. So sorry, that's cosine. And this was sine. You're right. See, I've lost track of which was which. This one is this one, right? Which is the sine. And the no. This guy.
So pi over 4 to 0 or 2 sine theta will only capture that section.
So, yeah. And those are sine squareds and cosine squared integrals, so they're not too bad, right? Let's see here. If I think about the shape of cosine theta, right? If I think about the shape of sine theta, right? And if you think about cosine theta from 0 to pi over 4, what's that? Right? That's like the thing we're squaring there and integrating from 0 to pi over 4, right? Sine theta going from where? From pi over 2, right, to pi over 4. It's this part of the graph squared, right? So if you look at the values that we're squaring, it's the same set of values, so these integrals are equal. So you can double either one. Yep.
Why do you add it not subtract it?
What do I what?
Why do you add what's over and not subtract it?
Because, because, right, I'm adding them because this piece right here is this integral, and this piece up here is that integral. So the sum of those two areas gives you the whole area, right?
Just assume that the integral would be the area of everything under the curve.
No. When we talk about polar area, we're calculating the area between the origin and the polar graph, sweeping between the thetas. So if you want to think about under, like imagine yourself on like a little planet, and it's like a two-dimensional planet, and like the center of gravity is the origin, so it's area under you is area like under towards the origin, then I would agree with you. But that's the sense under the graph. I mean, it's the area between the origin and where you're going to. Yeah.
Wouldn't that be the same integral added to itself and not 2 cosine theta squared? Wouldn't that just be 2 sine theta in both integrals with pi over 2 over pi over 4 is the balance for both?
Well, I don't know why you're saying that.
Because pi over 4 to 0, those bounds for cosine theta, that includes part of the circle that is not commonly shared between.
Oh, listen, I neglected to change these. I was discussing it, and I fixed one mistake, but I didn't fix this one yet, did I? Right? Right? Yeah. Yeah, when I find a mistake, you guys got to make me apply the correction to everything on the board, not just one thing, right? Otherwise, it leads to confusion. So I figured out that I had, yeah. Oh, and then my pictures are, but anyway, these are equal though, but whatever. All right, I'm going to erase this. I think we spent enough time on it. Yeah. Other questions? Ooh, apparently that brown marker is a magic marker. 10.2, 10 point what? 10.2, number what? 30? Well, I'm not going to use a graphing utility in here, I don't think, but if there's a calculus thing in here, I'll try to answer it. For you guys, we have x equals to e to the 2t, and y equals to e to the t. And it says use a graphing utility to graph the curve represented by the parametric equations, indicate the orientation of the curve, eliminate the parameter, and write the corresponding rectangular, sorry, I hate to say that, Cartesian equation. So I'm going to ignore the graphing utility part because if I find the Cartesian form of this equation, we don't need fancy schmancy stuff to graph it. We can just use like pre-calculus we all know. In particular, this is e to the t squared, right? Which means that this is y squared. So what you got? You got y squared equals to x. What is that? That is a sideways opening parabola. Yeah, it's one of these dudes. Now, however, there's fine print here, right? Notice that, right, x equals to e to the 2t is positive, and y equals e to the t is positive. So this part, while it's in the Cartesian equation solution set, it's not part of the parametrized curve, right? Parametrized curve. In fact, the parametrized curve doesn't even include the origin either, right?
Oh, wait, why is half the graph missing?
Because x is positive and y is positive, which means we're on this part of it, not that part. Down here we got y less than 0, right? So yeah, y squared is equal to x, but it's also got fine print. Which direction is it going? If we plug in t equals to 0, where are we? One comma 1, right? Because e to the 0 is 1 and e to the 0 is 1, so 1 comma 1. How about t equals to 1? Where are you? I think we're over here, right? T equals to 1 would give me, well, that's not a good, it's more like over here, right? Yeah, it's e squared, which is almost 9, right? And e, which is like almost 3, so it's like way out there. The point is, you can see the direction is this, right? Of course, we could have easily figured that out because what's the x dt? It's 2 e to the 2t, right? Which is positive. So this means what? This means curve flows, well, path, let's say. Path flows to the right. Maybe moves, it's better. Right? If dx dt is positive, that means it's a right moving path. X is increasing as time increases. 10.5, number 44. I can try if I can find it. Let's see here. Ah, here it is. Oh, sorry, Nathaniel. This is a rerun for you. Number 44. We're inside r equals to 2a cosine theta, and outside r equals to a. Supposed to find the area of the region so described. Now, again, I think for things like this, the algebraic approach is superior to the make a polar plot and use it approach. All right. So, I mean, when I see this, I know from my experience with you guys lately that if I multiply that by r, I get r squared is equal to 2ar cosine theta, which gives me that x squared is equal to 2ax, right? I'm sorry, x squared plus y squared, rather, right? Which gives me that x squared minus 2ax plus y squared equals to 0. Complete the square. X minus a quantity squared plus y squared equals to a squared. So yay, it's a circle. It's got radius a. And you know what? We're going to assume that a is positive. And so I can picture it. I've got a circle centered where? A comma 0, right? And it's got radius a, so it looks something like this. And then what's the other thing? Well, the other thing is r equals to a, right? So that's just that, right? And it said we're supposed to find the area inside 2a cosine theta and outside r equals to a. Where is that? Sort of the right part, right? So that's over here. Then the question you have to ask yourself is, is there a clearly defined inside and outside radius over the whole thing? If there is, then we can just use our standard setup. So take some rays, right? Look at that. Well, first of all, let me erase my stupid indication because it's in the way of my other. So I'm going to draw some. See that? No matter where you draw a ray from the origin, there's a clearly defined inside and outside radius, right? Rn is what? The green circle, right? Which is what? Just A, right? R out is what? Shh, I'm listening. Oh, okay, I'm sorry. 2a cosine theta? Okay. Sometimes the hallway is so very interesting. I have to try to listen. But 2a cosine theta. Nope. That's just. This black circle is r equals to 2a cosine theta. So the more interesting question is what does theta range over here, right? So you notice you got. Here's your max theta, right? And then like that, right? So theta 1 less than or equal to theta less than or equal to theta 2. How do you find those? Those are the points of intersection, right? So that's going to be where A is equal to 2a cosine theta. In other words, where cosine theta is equal to 1/2. Which gives us what? Plus or minus pi over 3. And then we just have to integrate. That's the easy part, right? I'm kind of only half joking. The integration is the part which doesn't really require as much thinking, ideally. You know what I mean? Like the setup is a lot of the trouble here, isn't it? So all of that motivates the following calculation, actually giving you the area. So the area should be equal to 1/2 the integral from minus pi over 3 to pi over 3 of pi r out squared minus r in squared, which is a squared. Let's see here, that would be a squared pi over 2 integral from minus pi over 3 to pi over 3 of 4 cosine squared theta minus 1 d theta. Just to clean it up a bit. And then, if you'll allow me, I would, if I personally would do this, I would say, well, this is symmetric about 0, right? So the integration, we can erase this, put a 0 here, and just double it. Right? And so we got ourselves a pi a squared. This is going to give me integral from 0 to pi over 2. That's a 2 times 1 plus cosine of 2 theta minus 1. Right?
So I don't see the bound change.
I doubled it.
From the second to the third line, it changed from the upper bound being 5 over 3 to upper bound being 5 over 2.
Oh, yeah, that's just wrong. Thanks. So this 2 minus 1 gives me pi a squared times theta minus sine 2 theta, I think. No, plus sine 2 theta. Evaluated from 0 to pi over 3 if I did it right. I think. Because the 2 minus, the derivative of sine 2 theta is 2 cosine 2 theta, which is what I have there. And then the 2 minus 1 gives me a 1. The 1 integrates to theta. So, is this what you got, Nathaniel?
I don't see where the pi comes from in the first line. That's not the area formula, is it?
Oh, no. I'm sorry, guys. This is what comes of me covering Calculus 1 today. I was doing volumes of revolution, where we put a pi in the pi r squared minus out squared formula. You know what I'm thinking of? But that's dumb. That's not what we're doing. Polar area is what? 1/2 integral of f of theta squared d theta, theta 1 to theta 2, right? For r equals to f of theta, theta 1 less than or equal to theta less than or equal to theta 2. And so, yes, there's no pi here. Good grief. Goodness gracious. You are justifiably confused. It is, in fact, a fictitious pi. It does not belong there. Much like Matt Lauer on the Today Show. Oh, I'm sorry, too soon. Let's hear. Sorry. Is there anyone safe anywhere? Like, I'm starting to, like, did you know Garrison Keillor do you guys know who Garrison Keillor is? He has also gotten fired for these reasons. Like, it's just bizarre to me. I mean, I'm starting to wonder, is there an end to this? Yes?
We found out who he is. Do we get
If you find out who Garrison Keillor is. If you don't, is the Prairie Home Companion? Yeah. Which I remember listening to in the car when I was little and wondering why we were listening to it mostly. Just, I don't know. But the sine of 2 pi over 3 is something. Yes.
Doesn't that exclude, oh, okay, it doesn't matter. Because, theta one and theta two, it excludes part of the 2a cosine theta of the circle, but that's inside, so that doesn't matter.
Yeah, we have to focus our attention on the part which is inside the one but outside the other, which
I
is,
think that's
yeah.
what was good.
Ah,
Okay. Because I couldn't figure out where to set up.
yeah, yeah. You guys should read Trump's tweets today. They're just mean. Like, just unfriendly towards NBC. It warmed my heart. But anyway. I gotta be careful. I'm gonna need to edit this one too. I don't think I've said anything needs to be edited just yet. Yeah. Ah, yes. I'm changing 3s to 2. I'm not sure you really want to ask me another question, but go for it. 10 point what? 10.4, number 44. All right, let's see what we got here. Oh, duh. 10.4, number 44. Ah. Yeah, I would say that this is one of those ones where you don't actually need a graphing utility. You can do this by hand. It's definitely a reasonable test question. R equals to, so he's got 3 times 1 minus 4 cosine theta. So I'm going to rewrite that as R is equal to 3 minus 12 cosine theta. Right? Then we follow the method that I always use. I'm going to draw a graph of R versus theta. You notice this is centered around 3. Okay, so if this is 3, right, then it's going up and down 12 from there. So basically this graph is between 12 plus 3, which is 15, right, and 3 minus 12, which is minus 9, right? And then I need to graph that. It's a cosine, though, so that's certainly something we can do. Minus cosine is kind of a little bit awkward, but if we plug in theta equals to 0, what do we get? So theta equals, yeah, we start out minus 9, right? Then, let's see here, pi over 2, pi, 3 pi over 2, 2 pi. So at pi over 2, where are we? 0, so we're at 3. We're right there, right? At pi, we're up to 15. Back down to 3 again. Back down to minus 9, so. Like that, roughly speaking. I'm not sure we even need that much. I sometimes like to go like, I find that this is often convenient to go back to like minus pi over 2, but I don't know, I have to think about it. Let's think through it. I mean, there's not a unique answer to this. It says give a range of theta, which the graph has covered, the curve is just covered once. I mean, there's infinitely many choices. So, yeah, well, we do. Let's start out here. Where would that be? We're solving 0 equals to 3 minus 12 cosine theta, and we're looking for a solution which is near pi over 2, you know? So that's cosine theta equal to 3 over 12. Well, actually, that's nothing particularly pretty. So, you know, you can calculate what's the inverse cosine of a fourth and see whatever that is. That's where that is, right? It's close to pi over 2, but it's not quite at pi over 2. All right. So let's try to create the graph from that. So we start out, that's a little bit shy of pi over 2, right? A little bit shy of pi over 2. And it's 0 again when we get a little bit past 3 pi over 2, right? A little bit past 3 pi over 2, which is like that, right? So let me call this theta 1. Let me call this theta 2, just for the sake of reference. All right? And what happens between those angles, a little bit before pi over 2, we start out at 0. When we get to pi, where are we? Radius 15. So if I use the same scale, it's like that. At pi, right? So we're looking at something roughly speaking. And what's it at pi over 2? It's at 3, right? So that's something like here on my scale. So that to be clear, use color coding for you guys. The blue thing I just did is the center hump of the cosine graph, right? Then I think it's most convenient to go back, for me anyways. I like to think about close to 0. So I'll think about this piece over here, all right? Which would go from what? From a little bit, it goes from theta 1, right? It goes from theta 1 to a little bit shy of minus pi over 2, right? So it's actually these two things again, right? But what? So in principle, it seems like it would be over here, right? But we have r is less than 0. So it's over here. And in particular, at 0, it's at minus 9. So it would be over here at like 9, but instead it's here because r is it's minus 9. So get one of these deals. And then you will just start repeating beyond there. So to be precise, I'd actually have to find the inverse cosine of a fourth, I guess. Inverse cosine of a fourth should give me theta 1. And then you can use that to construct the where it goes to. I mean, you could save that to plus 2 pi of that if you wanted. I mean, what if this is theta 1? What's this angle over here? What's theta 3? Can you guys tell me what theta 3 would be? Oh yeah, thanks. In other words, minus theta 1. I actually was not seeing that because I'm an idiot. I was thinking I was actually going to have to like work it out. But yes, it's obviously minus theta 1. Thank you. So we can go from minus theta 1 to minus theta 1 plus 2 pi, right? That is actually what I plotted specifically, yeah. Uh-oh. Sorry, I've gone
I
over.
don't know if anybody else has a question.
Unfortunately, I have to go. I have some obligation after this, which is much less exciting. And I'm not talking about harassing children. I mean, usually I play with the kids on Wednesday night, but something else. It's some boring math test.